Welcome back, everybody. Mr. Renneker here again. And in our next lesson for remote learning, guys, we are going to focus on exponents. So this is actually going to be a three-part lesson, so we'll try to keep these videos as brief as we can. Our objective here in this first part is to be able to write and evaluate powers, another name for exponents. So we got a little bit of vocabulary and then some quick examples to get going through, so let's jump into it. So for some vocab review, here it says a power is a product of repeated factors. So when you see here in the diagram, when we actually refer to this entire kind of number sentence, if you will, we would call that the power. Next, it says the base of a power is the common factor, the thing being multiplied over and over again. So the base in this situation, of course, as you can see here, is just the 1/2. Now the exponent, and this is where sometimes our language gets a little bit confusing. The exponent is just um, the digit that indicates the number of times this base is used as a factor. So the exponent is actually just the tiny little raised number here, just again indicating how many times do we multiply 1/2 or 5 or -2 or whatever else that is. So again, the power is the entire expression. The base is the common factor or the repeated factor, and the exponent is the digit that indicates how many times we use that base. So our first example should be a review for many of us. It says write each product using exponents. So we're going to write these using some exponents. So I see here in part A, we have -7 times itself multiple times. So since -7 is the repeated factor, I do know that -7 is our base. And then I'm going to count how many times we use -7, which is 1, 2, and 3 times, which means my exponent becomes a 3. So I'd rewrite this product as -7 to the third power. But the one extra thing that I have to actually add in here to be careful is because it's because the base is -7, I actually need to contain it inside of parentheses, and you'll actually see in a few more examples why that's so important. So if the base is negative, make sure that you have it inside of parentheses. In part B here, we have pi times r times r times r. So we do see some repeated factors. So let's see what that's going to look like once we condense it a little bit, simplify it using exponents. We're actually going to use each repeated base one at a time, meaning I have pi times pi, so pi would be my base, and of course it's 1, or there 1, 2 times, so I would write pi to the second power, or pi squared times, and then r is the second base, and it is there 1, 2, 3 times, so it would be r to the third power. So to rewrite this product using exponents, I would say pi squared r cubed. Of course, there's no a multiplication symbol here between them because multiplication is implied in mathematics, so you don't need to write the raised dot or anything else. We would just leave it as pi squared r cubed. Again, for many of us, that should be mostly a review, but if you'd like to test your understanding already, you can go ahead and pause the video, and in just a few brief moments, I'll make sure you can see some solutions before we move on. And both of your solutions would look as follows. We have 1/4 to the 5th power, and we have 0.3 to the 4th power x squared. For the second one, that decimal's in parentheses, mostly for clarification. Decimals can get a little funny looking otherwise, but we'll go ahead and move on to our next example. So here we're going to be evaluating some expressions, and you'll notice in part A and B there are a lot of similarities. It appears they both say -2 to the 4th power, and this is what I was mentioning just a few moments ago when I said the parentheses around a negative base are going to be very important, because when we read part A, we are correct. This does say -2 to the 4th power. Part B, we would actually be more correct to read this as the opposite of 2 to the 4th power. And it's the lack of parentheses that's going to change how we process that. Now, part A is pretty straightforward. It does say to take the base of -2 times itself 4 times, which the exponent indicates for us. And oftentimes, again, calculators can help us be efficient, but aren't just always necessary here. And you can process this however you want, but I'm going to start doing the numerical value first, and then I'll handle the sign of the answer second. I have 2 times 2, which is 4, 4 times 2, which is 8, and 8 times 2, which is 16. So that's what I mean by handling the numerical or the number part of our answer. But since it was -2, I'm going to have to go back through and process what the sign of this product will be a little bit more carefully. Some people might misremember our rules about multiplying integers from earlier in the year. They'd say, oh, all of the signs are the same, so the answer has to be positive. That may or may not be true, but that reasoning is faulty. The rule for multiplying integers, positives and negatives, only applies to when you're multiplying a pair or two values together, and we have four. So we're going to have to take this two numbers at a time. In other words, we have a negative times a negative. So a negative times a negative would give us a positive. So at that first part, multiplying 2, I have a positive answer. Then I would have to take a positive times a negative. So at that stage, now we would have a negative value. And then one more time, now we had a negative times a negative again. Well, negative times a negative leaves us finally with a positive. So it appears it actually is positive 16. But again, not because these are all negative values, but because we carefully matched two pairs at a time. Now, when you get to part B, however, this says the opposite of 2 to the fourth power. So guys, the base is actually 2, not -2. So if I wanted to expand this out, this would look like the opposite of 2 times 2 times 2 times 2, 4 times because the exponent was 4. And that's going to be the big difference here, because when I go to simplify it, well, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So that part's still the same. But again, we're reading this as the opposite of whatever that product was, meaning our final product is actually -16, or the opposite of 16. So while these problems, again, while they looked very similar to start, having or not having those parentheses surrounding the base definitely and intentionally changes how we process these problems. Again, some of this would be a review, although something here like example number 2 may not be, but those are the first things that you're going to do in this first lesson. So we have reached our objective, or you should feel comfortable getting started on it, writing and then also evaluating powers. Please reach out to me if any of this was confusing or you feel like you need extra tips to get started on your assignment. And as always, I will see you next time.